Back, everybody. So now we're going to take a look at the useWith function that is a popular one in Ramda. So let's start with the typed signature. It looks crazy, but we can just break it down into small pieces. The first thing we're doing is we're taking function here. It takes an x, and some more x's, but like x1, x2, x3, and returns a z. Okay. Then we're going to take a list of functions. We've got an array here. This is going to take an A, go to X, a B to go to X2, C to X3. That corresponds with these guys. And then it's going to return us a function that goes straight from A, B, blah, blah, blah to Z. So it looks like these X to Z functions are going to transform the list of functions that we pass in or something. Okay, yeah, so this is a wrapper function, and that's typical when you have the word with, is you're like decorating a function. And this array here is a list of transformer functions, so like mapping functions, and it returns the wrapped function. Okay, so what does it do? So it accepts a function, call it fn, and a list of transformer functions, these guys, and returns a new curried function, this guy. When the new function is invoked, it calls the function, this guy, with parameters consisting of the result of calling each supplied handler on successive arguments to the new function. Okay, this description needs a description. If more arguments are passed to the return function than the transformer functions, those arguments are passed directly to function as an additional parameter. If you expect additional arguments that don't need to be transformed, although you can ignore them, it's best to pass an identity function so that the new function reports the correct arity. Okay, so like an edge case of some sort. So let's break this down. The biggest clue right now is that it says see also converge, and I remember what converge does. So we've got our function that we're wrapping, math.pow, and transformer functions, and then some arguments. That's annoying. Um, I run that, and it is not running. I've got a problem. Try that again. Oh, is that function, or is it just my VS Code? Hey, that worked. But this isn't. Okay, it just got stuck. All right, so we get 81. So, okay, so the functions that we're passing are dot identity. They're not doing anything. Odd example. And it's showing that it's curried. If I do that and run it, I still get 81. So let's replace the functions with dec and int. Okay, and now it's clear. What's going on is it's going to apply the decrement function to the first argument. Let's go back and uncurry it. So it's going to apply this function to this argument and this function to this argument, and then call math.pal with the results. So very much like converge, except for converge would take both these arguments and apply it and get the result, and then apply this function to both these arguments, and then there would be the result. And then we would apply this function to this. So in converge, like this is the branching functions, and this is the converging function. But here, we're just saying we don't need to do the same thing to each argument. We need to, like, each function in here corresponds to each argument here. And then they have this thing, if more arguments are passed to the return function, like if we had 5 and we can't do that with math.pal, but if we could, it's just going to pass, well, let's read it. Those arguments are passed directly to function as additional arguments. So it's passed directly to here. It just ignores it. But they're saying that it's best to, if you do this, use our identity so that the arity of the function is reported as 3 instead of 2. That's what that is. I can't think of an example of something that needs more arguments, so I'm just going to go back to this. Yeah, so I mean, if converge is useful, which I think it really is, I think this is too. Because otherwise, we're going to need to say, like, we're going to have to store the result of applying decrement to 3 and increment to 4 in a temporary variable inside the function scope. And then once we have that, then we can apply this. So this is like you don't have to have multiple lines. And you couldn't really use pipe for this because it's just not one value flowing through the pipe. They're composed. Yeah. So I apologize. I can't really think of other examples. I feel like this is a pretty good one. I'm a little disappointed. I thought it was going to be a little harder to understand. And I need to stop doing that because the reason I thought that is just the sheer amount of words and the type signature. But once you start breaking things down, it's not that complicated. So that brings us to the end of the U functions, and we're getting real close to the end now. Um, Values we looked at when we looked at keys. It simply takes an object and gives you the values of the object. Like keys would take an object and would give you back the keys, ABC. Values gives you 1, 2, 3 in a list. And there's like object dot values in JavaScript. It's similar. Just remember it's only the own properties of the object, which leads us into values in, which we've looked at, and it's the same thing, but it looks up the prototype chain and will give you the values of the properties in the inherited object. As they specify here, they add a property called y well, a property called y, lowercase y, with the uppercase y as the value to the prototype. And then x is the own properties. But here you get x and y, and values, you just get the 1, 2, 3, just the values. Um, of course, in this example, they have not made a function like this. Uh, but trust me, it works because we looked at it. And we looked at view when we looked at lenses. So, bam, we just knocked that out. So now we've got, let's just look forward a little bit. We've got when and where any, where EQ, and without, and then a couple of X's and a couple of zips. Let's just keep going. So when is To see also if else unless and condition to logic. So, it's going to be like similar to an if statement. So, when takes a predicate function. That's probably the when part. When this is true, do something. Then it takes a transforming function, like a mapper function that takes an A and transforms it to B. And then we have our A, which is our data. And then we're going to return either an A or a B, depending on the predicate. So this is our predicate function. This is called the when true function, a function to invoke when the condition with this predicate evaluates to a truthy value. And then A here is an object to test with the predicate function and pass to when true function if necessary, like if it passes. And then it returns either the X or the resulting or the result of applying X to the when true false. So let's think about like if something is true, we evaluate the truthy branch. This is saying when a predicate evaluates to true, evaluate the transforming function. Otherwise, just give us back the value. So it's not like a if else, it's just like a when. And it's either you do the truthy thing or you just pass the value. You don't, there's no falsy branch. So let's look at this example here. Well, actually, let's read. Test the final argument by passing it to the given predicate function. If the predicate is satisfied, the function will return the result of calling when true function with the same argument. If the predicate is not satisfied, the argument is returned as is. It's like identity function at that point. So we've got a function called truncate, and when, and then our predicate. When the prop satisfies that it is greater than 10, and when what is greater than 10, when the length is greater than 10. It's been a while since we looked at prop satisfies. And if that's the case, we're going to take the first 10, append an ellipses to it, and then join it back together as a string. But when it's not, we're just going to pass the thing back. Let's try that. Let's truncate. And they're doing 1, 2, 3, 4, 5 as a string. Oh, there we go. And we get 1, 2, 3, 4, 5. Because the length of the string is only 5, 5 is not greater than 10, so we just return it. But if we grab all that mess, we get the formatted string 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which is the first 10. We ignore the ABC and we replace it with a ellipses, kind of like a read more sort of thing. Um, yeah, yeah. So that's what they're doing here. So basically, like if you have an excerpt in a blog post or something, you could determine how many characters to show, and if there's more than like 100, then you can add an ellipses, and if it's less, then you just return the untruncated excerpt. So yeah, that's pretty cool. So a lot of times we want to use an if statement, and they have an if else statement, but they don't have an if statement. And it's not even a statement, it's a expression or a function, both. Um, so you could do this with if else and do like a return the identity on the false branch or the else branch, but you still don't have this. Well, yeah, you would have a condition in an if statement. You might be able to do something similar, but like this is like the unless function, very convenient and keeps you from having to do things like double negatives, which in your expressions, which can be hard to mentally unwrap. Yeah, I think that's pretty good here. Let's move on to where and knock those out. The where takes a object, an object where the key is a string and the value is a predicate function that takes anything and returns true or false. And then we pass in an object and then we get true or false. So you see that pattern there? You're taking it like you're returning a Boolean or you're giving it a string or an object and returning a Boolean. And here it's checking the key of the object and returning a Boolean. So it's like this function is going to happen, it's going to run in between where you would just have an object that returns a Boolean. It's like you've got this function in here that's going to do some work. Okay, so this is a spec function. Like there's apply spec, which is really cool. You can go back and look at it in Chris's series. And then our test object and it returns a Boolean. So it takes a spec object and a test object, this and this, returns true if the test satisfies the spec. Each of the spec's own properties must be a predicate function. Okay, so each of these have to be a predicate function. Each predicate is applied to the value of the corresponding property of the test object. Yeah, so each value, the star, is what's being applied to the predicate. Where returns true if all the predicates return true and false otherwise. Where is well suited to declaratively expressing constraints for other functions such as filter and find. Okay, so let's look here. Take this. Yeah, very cool. So we've got this spec object where we're saying, okay, we want to end up with a property. Okay, no, we don't really want to end up with a property. We want true or false. But um, we're saying the A needs to equal foo. The B needs to not equal bar. That's what this means. X needs to be greater than 10 and the Y needs to be less than 20. And if all those things are true for the object that we provide, then this whole thing is true. If any one of these things is not true, if any one of these predicate functions do not return true, then the whole thing is false. So let's grab all these guys and clean it up a little bit. It's that one. And we'll do it like this. Just look at them one at a time. Oh, all right. So let's interpret this. Like let's pretend we're the JavaScript engine. This is our spec object, and this is our test data. So first we want to say, does A equals foo? And it does. Does B equal, first we check if B equals bar, and it does not, but we want the complement of that. So we want to see if equals, if it basically not equals. And B does not equal bar. 11 is greater than 10, but 19, and yeah, and 19 is less than 20. Yeah. So this should return true. Think about how much of a pain this would be without where. I mean, they're very simple calculations, but it's just you'd have to do like have to like write a lot of code. It's all separated, you know? Yeah. So we get true. Let's try these other ones. All right. So A is not XXX, does not, or sorry, this one, XXX is not equal to foo. Already we know it's false. XXX is not equal to bar, so that would be true. This would be true. This would be true. But it only takes one false to not be true. So this is kind of like all pass, which is another function that was looked at very early in Chris's original series. Um, but you have to pass in like an array of functions that you check. Here, it's much more tightly coupled to the object. I really like this pattern a lot. Let's do another one. The foo's equal to foo, bar is equal to bar, but we want the complement. So the bar is what messes it up. That's what causes it to be false. And then, because here, like, if you change your business logic, you just go change it right here in the value of the property in the spec object, and it's just like super simple. So these two are true, but this one is not. 10 is not greater than 10. It's equal to 10. So that's why this one is false. And then the last one is foo. B is not bar. 11 is greater than 10, but 20 is not less than 20. And so we get false. Very cool. And then let's check out where any, since it's related. Let's compare the type signatures. They both take this string predicate function, so it takes like this is a spec object where the values are predicates. It has the exact same type signature. Text out. Okay, exact same thing. Okay, so think about the name though, where any. So this means not everything has to evaluate to true. This looks like anything can. It takes a spec object and a test object. Each of the spec's own properties must be a predicate. Excuse me. Each predicate is applied to the value of the corresponding property of the test object. And then here's the deal. Where any returns true if at least one of the predicate returns true, false otherwise. So this is cool because this is sort of like any pass, whereas the where function is like all pass. Do you know what I'm going to do? I'm going to bring back that and clear my console. So let's change this to where any. And then I bet you, oh, that's my keyboard shortcut work. There we go. Let's just move all these in here and run it all at once. They're all true because something in here is true for each one, right? Foo is foo, so that's good enough. And the third fourth and fifth one are all foo. So it doesn't matter what the other ones are. But let's make one false. Let's make this foo. No, let's make this X. Let's make this bar because it's supposed to be not bar. And so the second one should be false, but it's not. Any of them can be true. That's not equal. That's not equal. Oh, but this is. So let's make this 10 and this 20. Now none of them are true, so it's false. Sorry. Yeah, in this one, in the second one, none of these satisfy the spec object predicate functions. So yeah, they're like complements to each other. You know, where checks if all of them are true, where any checks if any of them are true. Yeah, these are very cool. Um, and then let's check out this last one, and that'll wrap up this video. Is that the same type signature? No. This type signature takes an object and another object and returns a Boolean. And we're going to check if these objects are equal. With a spec object, so this is a spec object, and this is a test object. Takes a spec object and a test object, returns true if the test satisfies the spec, false otherwise. An object specifies the spec if, for each of the spec's own properties, not inherited properties, accessing that property, the object gives the same value in R equals terms as accessing the property of the spec. Where equals is a specialization of where. All right, I'm confused, so let's see. Okay, so here's our predicate function. We're going to say where A1 and B, so where A is 1 and B is 2. Okay, I mean, this is just as simple as it can be. I'm just going to write it like this. So if we check that situation and we pass it this object and we run, we get false because A1 matches A1, but there's no B2, right? So if we added another object or another property of B2, we run that, we get true. Yeah, I mean, so it just, this has to match this, but we're checking equality in terms of the R dot equals, which treats A, an object with A and 1, B with value 2 is the same thing as this. It's checking by value and not by reference. So, yeah, I mean, this is basically just checking if an object is equal to another object. What's confusing to me is that why can't you just do equals? Like, why can't I just say const dot or const obj equals um, a1 b2 and then do like r dot equals because r dot equals takes two things. That's one. So does that object equal the obj? And it is. So I'm a little confused of why. I mean, it's a specialization of where. Maybe it's just convenient. It was added in 0.14 and where was added in 1.1. So very early. some point, and this was added in 28, much later. Yeah, I don't know. I mean, they added it for a reason. I also don't check if objects are equal to each other a lot. So maybe my lack of experience in that particular use case is the reason why this isn't jumping out at me. But I really like these two functions, where and where any. And might as well do without before we finish up, just to finish up the W's. It takes two lists and returns a list. List one, the values to be removed from list two, and list two, the array to remove values from, and it returns the new array without values in list one. All right, so without, that's pretty straightforward. Let's grab this. And I'm going to run it, and we get 3 and 4. So we're saying we want this list without the values of this list. I can't really think of anything more to say about it. So yeah, without 1 and 2, here's our list. And we get 3 and 4 because 1, 2, and 1, and 1 repeats. So that's something to know. Yeah, so that's our W's. We've got two X's and 2 and 3 Z's, and then we're done. And then I know I've skipped some, but like I may or may not come back to them. My plan is to continue learning pure script, which I just love to death, and also to get into the sanctuary JS. And I'm almost doing it in order like that because I feel like Ramda is the easier because they're just functions, general functional programming functions. And then pure script is a little bit more complicated because you've got type safety, you got algebraic data types. Um, but Sanctuary JS is like in between. It's algebraic data types, uh, but I think it's going to be a little easier because it's JavaScript, whereas pure script is based on Haskell. So there's the complication of like working in a language that I'm not familiar with. That's the down the road. Um, so we'll stop here and pick up with XOR in the next video. Thank you for spending your time with me. Tell a friend, and I'll see you in the next video.